The cosmos is vast, dark, profoundly lonely. For all of human history we have gazed up at the stars and asked a single unifying question: are we alone? We sent our voices into the void, our probes to distant worlds listening for an echo, searching for a sign. On September 12, 2025, after a year of painstaking analysis and verification, NASA announced that the echo had finally returned. It didn't come from a distant star system or an advanced civilization. It came from our next-door neighbor, the rusty, dusty, seemingly barren world of Mars. The announcement was simple, yet it carried the weight of ages. We found life, we are not alone, and nothing will ever be the same. This is not a story of little green men or ancient abandoned cities. It is a story of the infinitesimally small, yet cosmically significant. The life discovered on Mars is microbial, single-celled organisms that have survived against all odds in the thin, cold Martian soil. So, what exactly did we find? When we say microbial life, what does that mean? Forget the complex creatures that roam our planet. We must shrink our perspective down to the scale of the truly small. Imagine an organism so tiny, millions could fit on the head of a pin. This is the world of microbes. They are the oldest, they are the most resilient, they are the most widespread form of life on Earth. They thrive in boiling volcanic vents. They survive the crushing pressure of the deep sea. They persist frozen in Antarctic ice. They are the true survivors of our world. And now, they are survivors of another world too. These Martian microbes are extremophiles, lovers of extreme conditions. They don't breathe oxygen like we do, instead they appear to be methanogens. They consume hydrogen, they consume carbon dioxide, they produce methane as a waste product. Mars's atmosphere is about 95% carbon dioxide. Its subsurface contains water ice, a source of hydrogen. They've adapted to use raw materials of a harsh environment. They are, metaphorically, part of the Martian geology. That's the level of elegant, efficient chemistry we're seeing. This monumental announcement wasn't the result of a single eureka moment. It was the culmination of a full year of meticulous, often frustrating scientific detective work that began in the autumn of 2024. The story starts with the Perseverance rover, our tireless robotic geologist exploring the Jezero crater. Its Sherlock instrument, designed to hunt for organic molecules, detected something unusual in a drill sample taken from an ancient river delta. It found complex organic polymers, chain-like molecules that are often, but not always, associated with life. It was a tantalizing clue, a biosignature, but it wasn't proof. The first hint of something more dynamic came a few months later, in early 2025. The rover's tunable laser spectrometer, an instrument designed to sniff the Martian atmosphere, registered a sudden, localized spike in methane gas. Methane on Mars is a ghost. It should be destroyed by solar radiation within a few hundred years, so any detection means it was released recently. This spike was different. It was concentrated near the very spot where the organic molecules were found. This correlation, the organic building blocks and the potential biological waste product in the same place, sent a jolt through the mission team. Could they be connected? The key to this entire discovery lies in the methane. For years, orbital probes had detected faint seasonal whiffs of methane. Rovers like Curiosity had detected them too. Was it geology or biology? Perseverance was built to solve that puzzle. The methane spike in early 2025 pulled the thread that unraveled the whole story. It wasn't just methane, it was location and concentration. The breakthrough was isotopic analysis performed by the rover. Elements come in different isotopes, slightly different masses. Biology prefers the lighter isotopes. When life makes methane, it favors carbon-12 over carbon-13. Geological processes don't show that bias. Perseverance found a carbon-12, carbon-13 ratio dramatically skewed to the light isotope. That ratio was the smoking gun. There were intense doubts and debates inside NASA. Could geology mimic biology? They tested exotic catalytic reactions with Martian minerals. They tested effects from cosmic rays. For weeks, a non-living explanation seemed possible. The suspense was agonizing. Doubt ended when Perseverance analyzed lipids from a deep core sample. Lipids extracted from the core showed clear patterns. Microbes ate nutrients and released gas. They were alive and active. The moment NASA Administrator Bill Nelson stood at the podium and uttered the words, "We have confirmed the existence of current microbial life on Mars," the world seemed to hold its breath. The reaction was instantaneous and global. News channels broke away from all other programming, social media exploded into a frenzy, shared awe, speculation, pure unadulterated joy. For a brief shining moment, geopolitical squabbles and daily anxieties were replaced by a shared sense of wonder. We as a species looked up. We looked up at that familiar red point of light in the night sky and saw it not as a rock, but as a world teeming with possibility. The scientific community responded with a mixture of elation and intense focus. Dr. Arati Prabhakar called it a paradigm shift for all of science. Richard Dawkins said, "For my entire career I have pondered the statistical probability of life elsewhere. Today, probability has been replaced by fact." This is the single most profound discovery in the history of biology since Darwin. World leaders were quick to weigh in. The President of the United States addressed the nation, calling it a discovery for all humanity. It was a rare moment of global unity, a recognition that this discovery belonged not to one nation, but to everyone on planet Earth. The discovery of Martian life doesn't mark an end, it signals a spectacular new beginning. The immediate future of Mars exploration has been completely transformed. Planned missions are being rapidly redesigned. New ones are being fast-tracked. The primary goal is no longer just to search for signs of past life, but to study current living ecosystems. The highest priority is a Mars sample return mission. While Perseverance's onboard lab is incredible, there is no substitute for the full power of Earth-based laboratories. Bringing a pristine, living sample of Martian soil back to Earth will allow for an unprecedented depth of analysis. This also brings up tremendous new challenges, particularly the issue of planetary protection. We must be extraordinarily careful not to contaminate Mars with Earth life, which could wipe out the native organisms. The long-term vision of sending humans to Mars now has a new, powerful impetus. While robots are excellent pioneers, complex geological fieldwork, future astronauts on Mars won't just be explorers, they will be field biologists, studying an alien ecosystem firsthand. The dream of a permanent human presence on Mars is no longer just about survival expansion, it's about stewardship, scientific discovery. Beyond Mars, the search widens. Europa Enceladus. The age of cosmic loneliness is over. The age of cosmic biology has begun. What discoveries await us next in the universe? If you enjoyed this journey, like, comment, and subscribe for more cosmic stories.